Hello everyone, I am Sushant from CSCC and my roll number is 37. Today I am going to explain about a simple code generator. Code generator is the last phase of compiler design. It generates a target code for the sequence of instructions, and it uses the getreg function to assign registers to variables. And also it uses two data structures. One is register descriptor and other one is address descriptor. Register descriptor is used to keep track of which variable stored in the register, and initially all the registers will be empty. And address descriptor is used to keep track of location where variables are stored, and location can be of anything like register, memory address, and stack, and so on. Now let us see the steps followed by the code generator. Let us consider an instruction L is equals to Y OPZ and assume that L is the location where the output of Y OPZ is to be stored. Here Y is an operand, Z is also an operand, OP is the operator. Okay. The first step we call getreg function to get the location of L. So to determine the present location of Y by consulting the address descriptor of Y. Okay, we determine the present location of y by consulting the address descriptor of y. As we know that address descriptor keep track of where the variables are stored. So by the address descriptor, we get the location of y. So if the y is not present in the location, then they generate the instructions move y comma l to copy y to l. So if the y is not present in the location L, so we'll move y to L to copy y to L. Okay. The present location of Z is determined using step 2 and the instruction is generated as OPZ, L. Now L contains the value of y OPZ, that is it is assigned to X. So if the L is a register, then update its descriptor that it contains value of X. Update address descriptor of X to indicate that it is stored in the location L. And the last step, if y comma z have no future use, then update the descriptor to remove y and z. So these are the steps followed by the code generator. Okay, now let us see an algorithm, how it works. So this is the algorithm. So the algorithm, it contains a function which has three parameters. One is operator, operand 1 and operand 2. As I mentioned earlier, x is equals to y opz. In that, y and z are operands. These are operand 1 and operand 2, and op is the operator. So first we'll check if operand 1 is present is present in a register. Like, but how we know it? How we know whether it is present in the register or not? By accessing the address mode. Okay, if operand 1 is present in R, then we'll check. Then we'll check if the operator, what the operator is. If the operator is plus, we will add operand 2 to R naught. If the operator is minus, we'll subtract operand 2 from R naught. If operator is multiplication, then we'll multiply, and if it is division, then we'll divide. So if operand 1 address mode is not R, then we go to this condition, else if. And now we'll check if operand dot address mode is equals to R. If the operand 2 address mode is R, then we'll perform the same operations with operand 1. Like if it is plus, then we'll add. If it is minus, then we'll subtract operand 1, and if it is multiplication, then we'll multiply, and if it is division, we will divide. In the last case, if operand 1 or operand 2 is not their address mode is not R naught, then we'll move one operand to R naught. So in this case, we are moving operand 1 to R naught, which is a register. Okay. If then we'll follow the same procedure, and we'll check if the operator is plus, minus, into, or division. Based on the operator, we'll add, subtract, multiply, or divide. So now I hope you understood the complete algorithm. Now let us see this with an example. So the example is as follows. The instruction given to us is x is equals to a plus b into c minus d plus e by f into a plus b. Okay, first what we need to do is to write a three address code for the given instruction. Here I have used six temporary variables. In T1 I am storing a plus b. In T2, I'm storing C minus D, and in T3, I'm storing E by F. Now in T4, I'm multiplying both T1 and T2, and in T5, I'm multiplying T1 and T3. So in the last, the resultant is stored in T6, which is T4 plus T5. So code generator is basically divided into four arcs. First one is three address code, next is target code, register descriptor, address descriptor. As we already know what register descriptor is and address descriptor. Register descriptor keep track of where the variables are stored in the register, and address descriptor stores the location. Okay, the first instruction, which is T1 is equals to A plus B. Now we need to move A into R0 register, and we'll add B to R0. Initially, as I said, all the registers will be empty. Now as we added B to R0, now R0 contains T1. So in the address descriptor, it shows where T1 is present. T1 T1 is present in R0 register, and the address mode is R. So address modes can be anything. It can be register, it can be main memory, or it can be stack. Here in our case, it is register. Okay. Uh, so the next instruction, T2 is equals to C minus D. Initially, we move C to R1 register, and we subtract D from R1. So R2 contains C, R1 contains T2. Now T2 is present in R1, and the address mode is R. Next, T3 is equals to E divided by F. Now we move E to R2, and we divide F from R2. So R2 initially R2 contains E, now R2 contains T3. So T3 is stored in the register R2, and the address mode is register. Okay. Next, T4 is equals to T1 into T2. We'll multiply R1 and R0 and R1. Why? Because T1 is present in R0 register, and T2 is present in R1 register. So we multiply both of them. Now the R1 contains T4. So here we can see the address descriptor. T4 is stored in R1, and the address mode is R. Now the next instruction is T5. T5 is equals to T3 into T1. Okay. T3 is stored in R2, and T1 is stored in R0. So we multiply both of them. So now R0 contains T5. As we can see, T5 is stored in R0. Okay. And the last thing, we need to store the resultant into T6. So T6 is equals to T4 plus T5. And now we add R1 and R0, because T4 is present in R1, T5 is present in R0. So finally R0 contains T6, and T6 is stored in R0. So this is all about simple code generator. I hope you understood everything. Thank you.